We'll proceed in sum series and integral calculus. Sum series and integral calculus, mind-blowing historical discussion that we are proceeding upon. Sum series and integral calculus. Can we find summation of a series through integral calculus? This is something that no one would have dreamt about it. That is it, it is really possible. Can I find summation of a series through integral calculus? What is the summation of series? Consider the summation of series is 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by n. Very famous. 1 plus 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by n. This is considered as something that is very famous. Can we find the summation through integral calculus? Okay, can I divide into n different parts? First, we will start from there. Can we divide this into n different parts? If I have one, if people are watching it, it is 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by n. Means there are n terms. Can I divide it into n different parts? Can I divide into n different parts? Certainly, we can divide into one n different parts, and each part is 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, like so. The parts are all are different. I was trying to mold into repeated summation. Repeated summation means if I have 5 plus 5 plus 5 plus 5, I can write as 5 into 4. I can write as 5 into x, where x is 4. I can rewrite as 5 into dx. If I change x to dx, then what x was 4, it will come through in limit. Limit of the integral is 0 to 4. 5 dx is same as 5 into x, where x is 4, which is same as 5 into 4, which is same as 5 plus 5 plus 5 plus 5. Makes sense? This is typically called repeated addition. If someone has repeated addition, he can convert into integral calculus. Result will be accurate if all the items are same. Okay, we'll try now. 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n. If I divide into n different parts, first part is 1 by 1, second is 1 by 2, third is 1 by 3. I can rewrite each part as same as 1 by x, where x is variable, 1 by x. Okay, now each part is 1 by x, 1 by x, 1 by x, 1 by x, 1 by x. If it is up to n terms. If I say if it is up to x term, then it is 1 by x into x. Okay, where x is n. I'm sorry, 1 by x into x. The last x is where x is n times we are multiplying 1 by x. Okay, but first 1 by x, I cannot say it is x equal to n. This is variable, this is varying upon x. This is dependent component. The problem of calculus is it is algebra. Calculus is nothing but operation on algebra only, but it identifies dependent and independent component. What is the equation of circle? X squared plus y squared equal to a squared. What is the equation of circle in calculus point of view? That is not correct. X squared plus y squared equal to 1 a squared is a correct terminology through the algebra, but through calculus this is not a correct terminology. Calculus need dependent and dependent and independent. In that fashion, if I have, okay, in that fashion, if I have x square plus y square equal to a square, then it has to be identified which one is dependent and which one is independent. I can say y is dependent, then I have to rewrite as x square plus function over x whole square equal to a square. Function over x equal to plus minus square root of a square minus x square. This is the formula. It is again same algebra only. But this is how calculus works. You have to discriminate between independent and dependent. Y is dependent and x is independent. Okay. In that manner, I'm trying to multiply 1 by x into x, where 1 by x is dependent function over x into x. X is independent. Fx into x is same as fx dx. Fx dx. Limit of x will be 0 to n. If I was doing 5 plus 5 plus 5 plus 5 4 times, 5 into 4, 5 into x, 5 into 4, 5 into x, 5 dx, the limit will be 0 to 4. If I am trying to add n item, then fx dx limit will be 0 to n. 1 by x dx, the integration will be natural log of x. Okay, log with base e. E means Euler. Euler was the mathematician who talked about base e. Base e means if you have base e, y equal to log of x base e means e to the power y equal to x, or x, or log of x equal to y, log of x up x equal to log of y, then e to the power x equal to y, dy by dx equal to e to the power x. Integration of e to the power x is e to the power x. He found a very funny number e. I believe that is near to 2.78 or something like that. If someone draw a graph with y equal to e to the power x where e is 2.78, something like that, then it will behave in a manner wherever you calculate the derivative, it will be same as what the height is. Make sense? If this is x-axis and this is y-axis, then at any x, I draw a graph called y equal to ex. I draw a graph called I draw a graph called, this is x-axis, this is origin. I draw a graph called y equal to ex. At any x, if I go up, it touches the e to the power x and there is a height. Okay, at that point x, if I do derivative, derivative will be of e to the power x is e to the power x only. Means at that moment, derivative means tan theta. Dy by dx means at that moment, if I take a tangent, that angle tan theta is the derivative dy by dx. At that moment, dy by dx will be same as ex. What is ex? Ex is the height at that time. Means more you go in x, the height of ex will increase, and accordingly, dy by dx will also increase. But it will be dy by dx, tan theta, the value of the tan theta will be exactly same as what the height is. Okay, what do you mean? At x equal to 0, e to the power 0 is 1. Do you mean that at x equal to 0, if I take the derivative of e to the power x, it will come as 1? Yes, then tan theta will be 45 degrees, certainly. It will be 45 degrees. But as you go from x more and more, e to the power x height will start increasing. Then dy by dx at that point, it will start increasing. It will start becoming steeper. At x equal to 0, it is 45 degree is the tangent dy by dx. If you grow, it will start going like perpendicular. After some time, it will more or less, it will become perpendicular. From perpendicular, and it will come to 45 degree, and this is it anyway. We are proceeding. So we have got, if it is 1 by x integration is, then integration will come as ln x, natural log of x, plus some constant, plus some constant. What is the constant? Can we try to fix it? What we have? 1 plus 1 by 2. 1 by 1 plus 1 by 2. 1 by x we are saying. If x equal to 2, then summation is 1 plus 1 by 2 is exactly 1.5. Okay, now here we have ln of x. X is 2. 2 ln is 0.7. I was searching it. It's not that I'm that intelligent that just in air I'm saying ln of 2 is 0.7. It is 0.7. I was saying it is 0.7. So if it is 0.7, ln of 2 is 0.7. On this side we have 1.5. Okay, means I have to settle the constant as 0.8. 0.8. Okay, let's try now. If I say x equal to 3, then ln of 3 is 1.1, means I was checking 1.1. So 1 point, here we have 1 plus 1 by 2 plus 1 by 3. So it will be 1 and a half plus 1 by 3. If I say 1 plus 1 by 2 plus 1 by 3, it will come as 6 as denominator. 6 plus 3 plus 2 it will come as 9 to 11. 6 plus 3 plus 2 will come as 9. 9 by 6. Okay, it is not 2. It will come as up 11 by 6. It will come as 1 point, then 8, 1.83. 1.83 it will come. Okay, 1.83. 1.83 equal to ln of 3, that is 1.1. If I subtract, it is coming as 0.7 only. Is it mind blowing? Let's try. X equal to 4. ln of 4 is 1.4. 1.41, 1 point, something like that. 1.4, consider. 1.4. So 1.4. And this side I have 1 plus 1 by 2 plus 1 by 3. That is coming as 1.83 plus 1 by 4. That is 0.25. So 1.83 plus zero point 0.2 will be 2.3. 2.3 plus 5, 2.8. Up. It will not be 2.8. Up. It will come as 1.83 plus 2.5. 8, 0 to 2.03. Up. 2.03. 1.83 plus 0.25, 538 and 280 to 2.03. 2.03 equal to ln of 4, that is 1.4. Okay, now if I subtract, it will come into 0.6, 0.63, 0.6, up, 0.68. Oh, wow, how I am calculating? 1.83 plus 0.25 is 2.08. 2.08, and I have 1.41. If I subtract 2.08 and 1.41, it will come below 7 also. Means the constant is decreasing. Let's take up. Let's take higher value. How much? How much? If I take x equal to 8, then if I take x equal to 8, then x equal to 7, then x equal to 7, ln of 7 will be very near. I believe it is 1.92, something it will come. It will be near to 2. If e equal to 2.78, then e into e, if I do 2.78 into 2.78, 2.8 into 2.8, how much it will come? 2.8 into 2.8. 2.8 into 2.8, how much it will come? Okay, someone has to calculate 2.8 into 2.8. I believe it will come as around 7 point something. Okay, 28 into 28 into 28. 28 into 28, how much it will come? 28 into 28, it will be 224, I think so. 224, 4 and 22 will remain. 28 into 2 is 56. 56 plus 22 will be 78. Means 7.8 around it will come. So if I take ln of 7.8, it will be ln of e square. 2 will go outside, ln of e 1, 2 will come. So let's take of 8. ln of 8, I consider it will come as 2.1 around. ln of 8, 2.1. How much is 1 plus 1 by 2 plus up to 1 plus 1 by 4 is 2.1 around. This is what we have calculated, 2.1. Okay, and here we have ln 2.8. 2.1, if I add 1.5, that is 0.2. 1.6, if I consider this again as 0.2, then 0.4. 1.7 will come around 0.15, then 0.55. 1.8, I consider now 0.1, 0.65 around, means 2.75. 2.75, and then we have ln of something is 2.1, ln of 8 is 2.75, 0.6, means it is decreasing. We started with, I believe, 0.8 as constant, it is decreasing. More or less we can settle down. After some time it will not change. After some time, people can see. At the beginning, The constant was changing rapidly. Now when I am moving ahead, it is roaming around zero point 0.6. I will, it will come around 0.57, and after that, if keep on increasing the sx, it will not change. 0.57. Now this is what we have got. The summation of 1 by x equal to ln, equal to ln of x plus a constant. That constant is 0.57. Someone can try, but that constant is will work only when x is higher. If x is low, then 0.57 will not work. Now we have taken example. Okay, what example we have taken? Consider that x is 1, then ln of 1 is 0. But first summation is 1 only. 1 equal to 0.57 will not work. Lot of gap is there. Okay, then lambda will be 1, means lambda people or constant will be 1. If I take x equal to 2, the ln of 2 is 0.7, and this side 1.5, 0.8 is gap. See the decrement. 1 to 0.8, it came in next word only. If I take point 1 by x equal to 8, it is coming near to 6. If I take x equal to 7, then if I take x equal to 7, ln of 7 is 1.91, 1.91, 1.92 around. Let's see this side. 1 plus 1 plus 1 plus 2 plus 1 by 3 plus 1 by 4. Up to 4 term, it is 2.08 plus 1 by 5. 1 by 5 is 0. 1 by 5 is 0.2 plus 1 by 6 plus 1 by 6. That will come as 0. 1.17. 0.2 plus 0.17, and 1 by 7, it will come around 0.14. Together it will become 0.17, 0.14, 0.3, and 0.2, 0.5. 2.08 already we have. So 2.58, 2.6. This side 2.6, and this side I have 1.92 at ln of 7. 1.92 or something, 2.6, 1.92. Then it will come as around uh, it that is not even 2.6, less than that. It will come around how much it will come? 0.64, 0.65. Means now the change is less. I believe for 8 it was 0.62 or something like that. And for 7.64. See the change. With 0.2 mere it is changing. If I take x and x equal to 1 and x equal to 2, it is decreasing 0.2. 1 to 0.8, 0.2, and here it is decreasing 7 to 8 at 0.04. So x is the constant is becoming stable once we move the x. So probably beyond 20 or 25, x will not change at all. So it will come as around 0.57. So at the beginning, the result may be not perfect, but toward the end result will be perfect. No, I want perfect result. Tell me, I want perfect. It is not available. Anyone can search in the book. Anyone can search in the book what is the perfect solution for this. Okay, this is what we found through repeated addition. We are going through two ways to find the solution. Two ways to find the solution. First is repeated addition. First is repeated addition. And in repeated addition, we are talking like this. What about successive approximation? What about successive approximation? Can we try finding out through successive approximation? Okay, many times we have demonstrated the concept behind the successive approximation. Every time that wand is out. Okay, successive approximation. This is what we are talking. Successive approximation means what we want. We have a function called fx, and that is 1 by x. We want sigma. x equal to 1 to n. Sigma means summation. Sigma sign x equal to 1 to n. Okay, if x equal to 1 to n, fx is 1 by x, means 1 by 1 plus 1 by 2 plus 1 by 3 up to 1 by n. This is what we want. Okay, consider this is x axis and this is what the graph is. X equal to 1, it is 1 and it will go like this. So at the beginning, x equal to 0, that we are not taking. 1, from 1, x equal to 1, 2, 3, 4. If someone takes a vertical, if someone takes vertical, if someone takes vertical, if someone takes vertical, when x equal to 1, then I have this vertical, that is 1. X equal to 2, then I have vertical as half. X equal to 3, I have vertical as 1 by 3. X equal to 4, I have a vertical as 1 by 4. X equal to 5, I have vertical as 1 by 5. So it will go like this. There is a function called 1 by x, but this is sampled at many places. It is not a continuous function. It is a discrete function which has an equation of 1 by x. Okay, let's take, I have another continuous function called gx, so that summation x equal to 1 to n fx will be equal to integration sign, limit lower limit to higher limit, gx dx. If I find a continuous function called gx, and then I do not integrate fx, because fx is, I can integrate, but that result will not be what we are seeing as summation fx will not be same. But if I have a continuous function gx, and let's say if I integrate gx, integrating means calculating the area. If this is gx, then underneath it is the area. What is gx? That underneath its area is exactly same as if I add all the verticals. If I add 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5, like that, if I add up to n terms, whatever will come in a result, if I take gx as a function and then if I calculate the area underneath, that should be exactly same. In that fashion, let's divide gx into several parts. How many parts? N parts. Let's divide gx into n parts. N part means this is x equal to 1. X equal to 1 to 2, there is one part. This is one sub area. Between 2 and 3, there is a sub area. Between 3 and 4, there is a sub area. Between n minus 1 and n, there is a sub area. Between n and n plus 1, there is a sub area. What do you mean by n and n plus 1? Because I have to divide into n different parts. Why you divide into n different parts? So that each sub area should be equal to one vertical line. One vertical line, yeah. 1 is 1 plus 1 by 2 plus 1 by 3. There are three vertical lines. 1 is 1 at x equal to 1. 1 is 1 by 2 at x equal to 2. 1 is 1 by 3 at x equal to 3. These three vertical lines will be matched with three areas. One area between x equal to 1 and 2. One area is between 2 and 3. And third area will be 3 and 4. Under a curve called gx. Okay, what are you trying to say? I am trying to say is that if I take any x, then I have a vertical called fx, that is 1 by x. The height is 1 by x. I am in a summation series of 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by n. If I take along x-axis any x, then I have in series the number that correspond to x-axis, x is 1 by x. That 1 by x will correspond to a sub area in gx, and that sub area will go from x to x plus 1, this sub area. Okay, if I have a vertical at x equal to x minus 1, that is 1 by x minus 1, then I have a sub area between x minus and x. Makes sense? Okay, in that fashion, I can say fx is 1 by x. 1 by x, fx at x equal to x is how much? 1 by x. 1 by x equal to limit x to x plus 1 gx dx. Okay, thank you very much. What is your grade gx? This is what great thing we have to find out. What is gx? If I know gx, then I can calculate for any limit to any limit. Gx I have to find out. Fx equal to limit x to x plus 1 gx dx. Okay, let's take it out. Fx equal to gx dx. Gx equal to dfx by dx. Dx equal to dfx by dx. Okay, if that is true, dfx by dx, if that is true, then how much it will be? Okay, fx is 1 by x, dfx by dx will be minus 1 by x square. Differentiation of 1 by x is minus 1 by x square. Okay, let's start gx with minus 1 by x square. Minus 1 by x square dx will come exactly as 1 by x. 1 by x, I have to set limit x to x plus 1. 1 by x plus 1 minus 1 by x. It will come as minus 1 by x into x plus 1. Makes sense? I believe it is alright. Okay, minus 1 by x into x plus 1. There are two ways now to see. What was expectation? The expectation was 1 by x, but we are getting minus 1 by x into x plus 1. Someone can see what is the difference between 1 by x and minus 1 by x into x plus 1. Someone can say how much it is less in the kind of division. If I divide 1 by x by minus 1 by x into x plus 1, it will come as minus x plus 1, minus in bracket x plus 1. That time it is different. So we will start if I multiply minus 1 by x into x plus 1 with minus x plus 1, then it will go away, only 1 by x will remain. Means I can change it now. We started with minus 1 by x square. I have to multiply with minus 1 plus x so that it will be settled down. If I see it, to settle it down, now we have to try now minus minus plus. We have to try now x plus 1 divided by x square integration. This is new gx. X plus 1 by x square will be 1 by x plus 1 by x square. Okay, if I do integration ln x minus 1 by x, 1 by x plus 1 by x square, this is new gx. If I do integration of 1 by x is ln x. 1 by x square, integration is minus 1 by x. I believe it is alright. 1 by x square, x to the power minus 2. Integration will be x to the power minus 1 by minus 1. Minus 1 by x. Okay, now it came as ln x minus 1 by x. Is it alright? Let's try now. Let's check the limit from x to x plus 1. X to x plus 1. If I set the limit to x plus 1, then how much it will come? Ln x plus 1. Makes sense. Ln x will be ln x plus 1 minus ln x. It will come at ln x plus 1 by x. Ln 1 plus 1 by x. Hold it. Now we have another one. Okay, minus 1 by x minus 1 by x. 1 by x plus 1 minus 1 by x, the way it was earlier. It will come as minus 1 by x into x plus 1, minus minus plus. Net it will come at ln 1 plus 1 by x plus 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 how what it is, plus 1 by x into x plus 1. This is what it will come. Okay, 1 by x into x plus 1 in denominator x into in bracket x plus 1 means ln 1 plus 1 by x plus 1 by x into x plus 1. If x is, someone can cross check it. What is ln 1 plus 1 by x? What is natural log of 1 plus x? What is natural log of 1 plus x? I believe natural log of 1 plus x is x minus x square by 2 plus x to the power 3 by 3 plus minus x square x to the power 4 by 4 plus x to the power 5 by 5. Something like that. This is what I think so. In that fashion, it will become 1 by x. Someone can cross check it. I'm not sure about it. Okay. Someone can find this is Maclaurin series. Logarithmic of x is difficult to find. If I do logarithmic of x, then if I try how, then it will be difficult. To getting Maclaurin series is, first you have to get value at x equal to 0. So logarithmic of x equal to 0 is undefined. So we cannot calculate. Logarithmic of 1 plus x we can try. If that is the function, then x equal to 0, it is logarithmic of 1, that is 0. Now I have to do first order derivative. Logarithm of 1 plus x, the derivative will come as 1 by 1 plus x. 1 by 1 plus x into x into x. Okay, into x. Hope something like that. Okay. So 1 by 1 plus x into x. Next will be double derivative of it. So first derivative is 1 by 1 plus x. Next derivative will be minus 1 by 1 plus x whole square. Okay, into x square by factorial of 2. Okay, x square by factorial 2 will remain. Now this derivative I have to calculate at x equal to 0. That is the Maclaurin series. So more or less it will become, first was 1 by 1 plus x is 0, it will become 1 into x by factorial of 2. Makes sense? Next is dual derivative. Dual derivative will come as minus 1. Dual derivative will come as minus 1 by 1 plus x whole square, something like that. It will remain as minus 1. Minus 1 into x square by factorial of 2 minus x square by 2 plus triple differentiation. Triple differentiation will come as sum 2 by 1 plus x to the power 3, 2 by 1 at x equal to 0. X to the power 3 by factorial of 3, that will be x to the power 3 by 3. Alright. So the Maclaurin series of logarithmic 1 plus x is x minus x squared by 2 plus x to the power 3 by 3, not factorial, minus x to the power 4 by 4 plus x to the power 5 by 5 minus x to the power 6 by 6. Make sense? Okay. We calculated Maclaurin series. Anyway, someone can try putting logarithmic ln 1 plus 1 by x. What we have seen now. So ln 1 plus 1 by x, if I break it through Maclaurin series, then it will come as 1 by x minus 1 by 2 into 1 by x square. Makes sense? Plus 1 by 3 into 1 by x to the power 3 minus, the way it will go like that. And then we have after that plus 1 by plus 1 by x plus 1. 1 by x, 1 plus x, I can say more or less it is equal to 1 by x square. Means if I take only two series of Maclaurin series, then it will come as 1 by x minus 1 by 2x plus 1 by 1 minus 1 it will come as x plus 1 by 2 into 1 by x square minus, and this side we have plus 1 by x square. Okay, and then the way it will go along like that. Okay. Okay, more or less we can say this is what extra we are getting. Someone can settle it down. Someone can settle it down. If x is higher, then more or less all term will go away, claiming 1 by x square will go away. More or less it will come at 1 by x. Okay, I'm not satisfied what you are saying. Let's try another way. Natural log of 1 plus x, if x is little high, then it will be near to 1 by x only. 1 by x plus 1 by x into x plus 1. 1 by x I can take outside. Okay, then it will become 1 plus 1 by 1 plus x. If I settle it down, it will become x plus 2 by x plus 1. If x is higher, then it is 1 only. X plus 2 by x plus 1. If it is higher, it is 1 only. More or less, we have settled it down. Means it will come as 1 by x only for higher x. More or less, it is alright. Whatever we had thought that gx equal to x plus 1 by x square or 1 by x plus 1 by x square, it is all right. If it is not all right, then people can consider more toward it. More toward in a sense that Maclaurin series expansion someone has to do. ln 1 plus 1 by x, and then someone has to add with 1 by x into x plus 1 and see, take two terms, three terms, and see whatever extra is coming from 1 by x, and whatever we had taken x plus 1 by x plus 1 by x square, in that I have to settle down with the next term. Okay, I have to settle down with the next term. Someone can try what is there in trying. I believe it will come as someone has to subtract with here we have 1 by minus 1 by 2x square plus 1 by x square. How much it will come? 1 by x square minus 1 by 2x square. Okay, it will come as 2x square minus x square 1 by x square minus 1 by 2x square. Someone can take out 1 by x square. 1 minus 1 by 2. 1 by 2. 1 by 2 x square will be extra plus. So I have to subtract now x 1 by x plus 1 by x square minus 1 by 2 x square. Then now it will be settled down as 1 by 2 x square, not 1 by x square. Then someone can try again. Make sense? If someone try again, then this first term will go away, and then proceeding to that. Okay, we will see it. Let's try with the 1 by x plus 1 by x square. Then we'll try with 1 by x plus 1 by 2x square. I believe it is all right. Okay, up. Yeah, it is all right. Okay, one will try with 1 by x plus 1 by x square. If I do integration, it will come at ln x plus plus minus 1 by x. ln x minus 1 by x. Integration of 1 by x square is minus 1 by x only. Natural log of x minus 1 by x. Now what will be the limit? We are taking right hand side. This is a very big discussion. This is under research only. No one knows the actual solution of. We know whatever we are saying, it is exactly all right. Now this is the only way where it will come exact solution. This is a $1 trillion solution. No one in the world has come to this solution. Amazing, mind blowing. Okay, now which limit I have to take? If this is fx, then we have to start from 1, x equal to 1, 1 to 2, 2 to 3, 3 to 4, like that. Then at the end we have to take x to x plus 1. More or less it will go from 1 to x plus 1. Limit will be 1 to x plus 1 ln x minus 1 by x. Let's settle down x plus 1 first. Then ln of 1 plus x minus 1 by 1 plus x. Okay, let's settle down 1 now. Now full minus and in bracket ln of 1, that is 0. And then minus 1 by 1, that is 1. Means it will come as outside minus is there, minus minus plus 1. It will come as plus 1. If it comes as plus 1, then how much it will be? It will be ln of x plus 1 minus 1 by x plus 1 plus 1. Okay, if I had taken after the Maclaurin series adjustment, we came that it will be 1 by x plus 1 by 2x square. That will be better term. If I try with that, then it will be ln x minus 1 by 2 into x. Makes sense? If I set x plus 1, it will be ln x plus 1. So ln x plus 1 will be there. Minus 1 by 2 in bracket x plus 1. Minus, and in bracket we have to settle with 1. ln 1 is 0. And minus 1 by 2. 1 by 2x is there. Minus 1 by 2. Minus plus 1 by 2. Means it will come as ln of 1 plus x minus 1 by 2 in bracket x plus 1 plus 1 by 2. First came as ln 1 plus x minus 1 by x plus 1 plus 1. Second came as ln 1 plus x minus 1 by 2 in bracket x plus 1 a denominator only. plus 0.5. Okay, someone can, I believe we will proceed in discussion. Anyway, someone can try. What about x equal to 2? If x equal to 2, then solution is 1 plus 1 by 2, 1 and half. Let's try here. ln of 1 plus x, ln of 3. ln of 3 is 1.1. If I try with the first solution, 1.1 minus 1 by 3, 1 plus x. 1 by 3 will come as 0.33. So 1.1 minus 0.33, how much it will come? It will come around 1.78. It will come around 1.78. 1.1 minus 1.1 minus 0.33. It will come as 7. 7. Up. And then it will come as again 7. 0.7 up 0.77. Yeah, 0.77. 0.77 plus 1, 1.77, but actual result is 1.5. We'll try with our next solution, that is ln 1 plus x by 1 by 2, 1 plus x plus half. So first will come as 1.1 minus 1 by 2 into 1 by 3. Okay, 1 by 6. 1 by 6 will come as how much it will be? 0.17. 0.17. 1.1 1.1 minus 1.7 will come as 0.93, I think so. 0.93 plus 0.5. Up. It is very near. 1.43. So it is better. So we can proceed in Maclaurin series. Maclaurin series through this, that we went for next approximation. Okay. First we started with minus 1 by x square. Then we came that it is not it. Then we multiplied by minus 1 plus x as numerator, and it came as 1 by x plus 1 by x square. Then we came, it is ln 1 plus 1 by x minus 1 by 1 plus 1 minus 1 by something like that. I forgot. Okay, 1 by x into x plus 1. I expanded ln 1 by 1 plus x through Maclaurin series, and we settled it down. Then we came to know that we have extra 1 by x square that we have put. Then I have to subtract it by 1 by 2x square as per the next approximation, because it should be similar to 1 by x. But 1 by x, we have something extra. Then we resettled with 1 by x plus 1 by 2x square. And it is coming at ln 1 plus 1 by ln 1 plus x minus 1 by 2 x plus 1 plus 0.5. Okay, now it is variable. If you see anywhere, the solution is ln x plus 1 lambda. Lambda is a constant, but here it is not constant. As we grow in x, then 1 by 2x plus 1 will also grow. I mean, it will shrink. It is denominator, it will shrink. So more or less, the answer will be more perfect. Okay, try now. What is more perfect? What is try? Let's try x equal to 4 then. If x equal to 4, then 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Okay, it came as 2.83, I remember. 2.08. 2.08. 1 plus 1 by 2 is 1.5. Plus 1.5, 1.4 is 1.75. 1.75 plus 0.33 will come at 2.08. Not try with your ln 1 plus x. X is 4. Natural log of 5 is how much? It is 1.6, I think, around 1.6. So it will come as 1.6 minus 1 by 2, 1 plus x. X is 4. 4 plus 1, 5 into 2, 10. 1 by 10 minus 0.1. Minus 0.1. So it will come at 1.61 minus 0.1. 1.51. 1.51 plus 0.5, 2.1, here 2.0, exactly correct. If I go with the next Maclaurin series, then it will come exactly correct. This is something that no one had invented. I am 100% sure about it. This formula is not available anywhere else. I have not taken bigger series. This much only is enough. That is equation of finding the kind of summation is natural log of 1. Anyone can try anywhere. Now nothing is hidden. You can just type in and search. ln 1 plus x by ln 1 plus x minus 1 by 2, and in denominator bracket 1 plus x, 1 by 2 1 plus x plus 1.5. Anyone can try. This is not there anywhere else. If someone is more perfect, then he can go more in Maclaurin series and settle it down for the next term. Amazing, mind blowing, brain hitting in the wall. Anyway, we will see it, and then we will see left side also. Okay, right now we tried right side. So we are that also we are doing. Right side means if this is x axis, this is x axis, and this is gx, then we tried from 1 to 2, 2 to 3, from x to x plus 1 as the limit at the beginning. Next, we will try left side, means x minus 1 to x. If at any x I have fx as fx, that is 1 by x, then gx we will integrate x minus 1 to x. Right now we were integrating x to x plus 1. We will integrate x minus 1 to x, and we will see what it will come. Both should be same and amazing, mind blowing. This is something would have felt Nobel Award in mathematics. I am sure about it. This is amazingly different. Okay, please do not mind supporting us or mind supporting us. Plus 91 is the India country code 9483160610 is the telephone number. Plus 91 is the India country code 9483160610 is the telephone number. I did not prepare much on it. I tried to see it. I thought that if no one has found the solution, our solution will also be something that will be weird only, but doesn't look like so. It is perfect. Anyway, we will see on it.